Imagine staring 4.3 billion kilometers into the darkness of space and seeing Neptune not as a blurry blue dot, but in breathtaking detail. For the first time in over 3 decades, we now have high-resolution, real images of Neptune, thanks to the James Webb Space Telescope. What these images reveal is not just a clearer picture of this distant planet, but entirely new layers of information that were invisible to us before. The last time humanity got a close-up look at Neptune was in 1989, when NASA's Voyager 2 spacecraft flew past it, capturing the first and only detailed views of the planet until now. Webb's ability to observe in infrared light gives it a powerful edge, allowing it to pierce through Neptune's thick, hazy atmosphere. And the differences between what Voyager saw and what Webb now captures are astonishing. In the new images, Neptune doesn't appear blue as we usually know it. Instead, it's a ghostly white orb with bright streaks and rings. That's because Webb sees infrared light, not visible light. This spectrum cuts through the methane-rich clouds and reveals details beneath Neptune's upper atmosphere. One of the most dramatic reveals in the new images is Neptune's ring system. Yes, Neptune has rings, and many people are unaware of this fact. Webb's powerful infrared vision captured 6 well-defined rings, including some of the fainter ones that hadn't been seen clearly since Voyager 2. These rings aren't like Saturn's wide, icy ones. Neptune's are darker and dustier, and they likely formed from fragments of moons or other debris pulled into the planet's gravitational field. The clarity of these rings in Webb's images opens a whole new door into understanding their composition, age, and behavior over time. But the atmosphere is where things get really interesting. Bright spots dot Neptune's disk. These are massive methane ice clouds floating high in its atmosphere. These clouds are incredibly reflective, and Webb's instruments allow scientists to observe their structure and movement. Even more mysterious is a bright band encircling Neptune's equator. Scientists think this could be a zone of rising warm gas, where it cools, condenses, and forms clouds as it moves higher into the atmosphere. It's a dynamic that has never been observed so clearly on this planet before. Let's not forget about Neptune's winds. They are the fastest in the solar system, reaching speeds of over 2,000 kilometers per hour, faster than the speed of sound. These new images give scientists a chance to track how such wind systems interact with cloud formations and atmospheric bands, building a more complete picture of Neptune's weather. In the same frame as Neptune, Webb also captured 7 of its 14 moons. But the one that stands out the most is Triton, Neptune's largest moon. In Webb's images, Triton shines brighter than Neptune itself. That's because it's covered in frozen nitrogen, which makes it highly reflective. Triton isn't just another moon, it's a captured object, likely a Kuiper Belt object, that was pulled into Neptune's orbit. And it orbits backward, against Neptune's rotation, a clear sign that it didn't originate there. Triton's reflective shine isn't the only thing that's caught scientists' attention. There's strong evidence suggesting it might have a subsurface ocean one that could potentially harbor microbial life. This puts Triton high on the list for future exploration. Could it be the key to understanding icy worlds across the solar system? Neptune's place as an ice giant is also critical. Unlike gas giants like Jupiter and Saturn, Neptune and Uranus have icy cores and different atmospheric compositions. Studying Neptune helps scientists understand not just our solar system, but planetary systems across the galaxy. Ice giants are among the most common types of exoplanet discovered so far. The more we understand Neptune, the more we understand the makeup of other solar systems. What's also incredible is Neptune's extreme seasonal behavior. A single season on Neptune lasts 40 Earth years. Imagine winter lasting for 4 decades. With Webb's ongoing observations, we might be able to track how these seasons affect the atmosphere, ring visibility, and cloud dynamics over time. The James Webb Space Telescope is only just getting started. Future observations of Neptune are expected to map its magnetic field in more detail, monitor changes in its atmosphere, and potentially discover even more moons. We are entering a new era of planetary science, and Neptune, once an enigmatic blue orb at the edge of our solar system, is now being brought into focus like never before. So, what have we truly found in the first real images of Neptune? A clearer view of its dynamic rings, a complex atmosphere with bright methane clouds and powerful wind bands, an equatorial heat belt that suggests intense atmospheric circulation, and Triton, an icy, mysterious moon that may hold secrets beneath its frozen crust. For decades, Neptune has been one of the least understood planets in our solar system. But thanks to Webb's powerful eye, that's beginning to change. These images don't just show us what Neptune looks like, they hint at what it is made of, how it behaves, and what its history might be. And perhaps most exciting of all, they remind us how much we still have to learn. Because even at the very edge of our solar system, in the cold and dark, there's still beauty, mystery, and discovery waiting to be seen.